Thank you again for coming. Now, coming to the topic, I will quickly explain what the project is that I'm working on and how and why we are using Databricks. So the project that we are working on is for electric vehicle data analysis. And in this, we have a lot of use cases, but one of the major use cases consists of data where we analyze the charging events, where we get a lot of metadata, including when the cable was plugged in or plugged out, and all of the battery status, and as to what the current charge was and what the charge was when it was plugged out. And also the ignition status of when it was ignition on and off, warnings and alerts from the vehicle system as well. We analyze all of this data, and this data that we get is in JSON format. And the JSON data contains all of these components in one object. And this object can be like multiple objects in one JSON file. So now, and these files are really small, ranging from around 5 to 10 megabytes per file. And if you have worked with PySpark, you might know that there is a problem called small file problem, where it is really inefficient with small files. And the optimum file size is around 128 megabytes. So we get around 5 to 10 megabytes, and that's where the huge performance bottleneck is. So the challenges faced is, like I explained, the small file issue and monitoring and maintainability of all the services. So for the whole data pipeline, we have glue jobs, we have glue workflows, crawlers, and Athena, and S3. So maintaining all of these, and you don't get a clear picture as a developer, and it gets a little difficult to maintain all of these services for multiple brands. So we have multiple tenants, and we have this data analysis for all those tenants. So multiple tenants versus multiplied by all of these services, it gets a lot. So in order to fix this, what was the solution? We decided to migrate from Glue to Databricks for all our processing and data pipeline. Okay, again, the original data flow was like, and this is a very simplified statement, just to show, because if I get into the details, it's a lot going on in the background. But just to simplify this, the data we received, the JSON data, was uploaded to S3 from, say, team ABC in all of these JSON files, and we had glue jobs, crawlers, and workflows. Glue jobs, if you don't know, is a platform where you can have your Spark code running, and you can read from your data source. For example, it could be any database or S3, or it could also be like tables on your Glue catalog. So yeah, glue jobs are your data processing with code. Crawlers are, if you say have a data set on S3 and you want to create a table out of it, which you can later do some analysis on using Athena, you run a crawler on that folder. And workflows is just orchestration service on Glue itself, where you can chain multiple glue jobs together and have like a nice status and also have retries if it fails. Okay, so issues again, we had performance bottlenecks, not just from the small file problem, but also at the logic level itself. and increased total cost of ownership, because in cases where we had to sometimes reprocess the data for the entire period of data that we received or a specific portion of time, it was really difficult because all of these input files that we got were not partitioned as well, and yeah, just pinpointing to a particular for a certain month was really difficult. And also, like, if you had to then read all of the data and then filter out for just a specific month and then do all of this reprocessing, it costs a lot, and similar problems we had. So this added to the whole cost. Now with the new workflow, new data flow, we get the vehicle data. There's also a lot of stuff behind this. We have a separate microservice script, a Python script, a simple Python script that sends all of this data to event hubs. From there, it's easy for us to then process using Databricks in batches. And we have a very, there is also one more feature from Event Hub, which is for every message there is an offset value. So in case you want to process for a certain period of time, you just have to pick the offset, tell it just read from this offset until this offset, and then you can just process that much data in case you want to reprocess. And yeah, on Databricks, we have like unified storage and processing architecture, which I will explain in the next slide. So Databricks, unified platform. So on Databricks, what you get is you have notebooks. If you don't know what notebooks are, these are platform where you can again write all your code, and you have a certain functionality called as cells, where you can just test the script like in chunks of the code. So it makes it easy for your developers to like test the code block by block and see where the performance bottlenecks are. So yeah, you have the notebooks, you have also workflows, all in the same, under the same roof. Like, you open the Databricks UI and you see all of the components right there. So there's notebooks, there's workflows, there's like you have the catalog as well, where you can create your delta tables, and this catalog also has an inbuilt SQL editor, which you can use to query all of these delta tables and make your analysis. So it's all in one like simple UI. And yeah, with Databricks, you also have like scalable architecture. You can easily use like Photon engine that I have in the last point, which is if you have a lot of bulk data that you want to process at once, there's a small switch just to turn it on the Photon engine, and then you can process we observed at least 4x performance. Of course, it will cost you a bit more, but yeah, in terms of performance and processing, if you want like a temporary boost, you can use the Photon engine. And of course, from a cluster point of view, you can have horizontal scaling as well. So yeah, so what problems did we solve with Databricks? Yeah. So a small file issue, once we started doing this stream batch processing using event hubs, we didn't have to worry about the small file issue. We could just read whatever we want, and we also have like a checkpoint as to until which offset have we read, and then for the next load we can read directly from that offset onwards. So we fixed the small file issue, and also the event hub buffer overload, which like I said, once we started receiving all of these events in the event hub, there was like a huge surge of records, and it exceeded like 1 million. It was around 1.5 million at once, and that's where we use the Photon engine for faster processing. And yeah, it was able to catch up with all of the previous events, and then we had the daily job running going forward. Yeah. And there was also another problem with the schema. So like I said, this data is in JSON format, and there is no guarantee that you will receive all of the fields in the JSON. But we had all of this considered in the code, but there are certain keys or certain what do you say? Certain keys in the object in the JSON that where the data is actually expected, and they were missing, which caused our jobs to fail. So now with Databricks, we don't have to worry about that. And why? My friend Arman here will explain in the further slides. And also about the failure notifications, we earlier had only SNS notifications for failed jobs or workflows, but now we can have much more at every small stage of your data pipeline, we can have much more notifications. Also will be covered in the upcoming slides. And in case sometimes what happens was that our jobs used to fail right in the middle, and some data used to get written, but the rest was it's failed, right? So now we can't proceed with this kind of data. So with Databricks, what you have is a rollback feature where you can just roll back your delta tables to the previous good version, and then you can try your reprocessing, go back to the code, correct it, and then go forward. And that's all from my side. I think Arman will take over from here. Thank you.
Thank you, Adit. Hi. Here you saw some challenges that we had for the project, and for some of them we tried to fix them or have some solutions to make it better. But then we thought, okay, maybe we can have a new idea for the whole solution, for the whole pipeline, to make it better with the new idea of our project. So we saw it that maybe we can use the delta live tables of the Databricks for our project and creating our pipelines based on the Medallion architecture, and maybe it can help us. We also had it for some other projects, and we had some experience on it. So we tried to find solutions for the challenge that we had, an overview with the delta live tables that we are going to see them together here, but just a brief overview about Medallion architecture, that we can have 3 layers of data: bronze, silver, and gold layer. That in the bronze layer we have, this is our landing zone, that we just load the data that we have from the sources. Then in the silver layer, we can define our structure and some schema enforcing, for example, that needed, or some cleaning of the data. And then in the gold layer, we can have our business level aggregates that we can use it, for example, for dashboards, for KPIs, for any other use cases that we need. For this, the delta live tables offer us with many features for Medallion architecture that we used most of them for our challenge that we had here. The first starting, we're going for the first part of the architecture, that we are going to read the data. As you saw, we had many small files that we need to read these files and process them. So we thought that maybe we can use the ingest of the delta life table, then with this we can have two types of ingest, for example, for streaming data and for batch data. And the good news is that we don't need to, after this, we don't need to have two separate logic for this data. We can just read them, and then the other parts we can have just one logic for the data. And it also supports if in future we need to have a new schema, for example, for file, we can just easily change it. Or if in future we just need to add a new source, we just need to add a new ingestion for the data. These are just two example code that we had on the left side. You can see the code, sample code for reading from streams. And like Kafka or Event Hub, and on the right side you can see for batch data. So this was our, actually this helped us for fixing our first problem. So just one time we need to read the small files, and then we kept all of them in the delta format in our bronze layer, and then it has a very, very high performance for us for querying, and then we can have multiple queries on the bronze layer. Then when we read the data, again, we wanted to have a better performance for our calculations and the next step, for example, transformation and enrichment. So we use the materialized views of the delta life tables, and we try to join these ingestions that we had from the first layer to this layer. So you can see we don't need, from this side, we don't need to have different logics for different sources of data, so we can just add sources and use them here. And the backbone, it uses the Delta Lake feature of the Spark. And with Delta Lake, what we have ACID transactions and versioning. With these two, if our pipelines fail, for example, for any reason, it's store the whole result or nothing. So if failed, we don't have wrong data on our next layers, and we can just easily find that, okay, what was the problem, and rerun it again. So our results are not wrong anymore. Or if we had some pipelines, and for example, after some days we found that, okay, there is a problem in our calculation, we can easily roll back the data to a day before, for example, yesterday. Or we can roll back the data based on the versions, like last version. So with this feature, we fixed our problem that we had about failures in data or wrong data that we had in our pipelines, and easily, without having a very long logic, for example, for rollback, we can easily use the delta files to use this logic. And for the delta, we have the optimized Databricks execution plan that we can easily run our queries on top of it. Then the next challenge that we had was the data quality. In the data quality, sometimes we had a big JSON files that we didn't know. Okay, sometimes there are some fields are null, or sometimes so that, okay, a field shouldn't be higher than a number. And when we had this data, we need to manually have some code to find them. Sometimes we need to fix them or filter them for the data. But we found that with the data quality features of the DLT, we can easily write them with the query language with or SQL language, and we can easily manage it, or DLT will manage it for us, and we just tell DLT about this. So now we are going to read some of them. For example, the first one, constraints that we can have for our layers, every layer, bronze layer, silver, and gold layer. We can have constraints to they shouldn't be null, for example, or some checking, like it should be a valid time format, or it should be a number, for example. So we can define all of them on column levels for the tables, and in each step, when we are checking the data, we can find out, okay, where is the problem? Then we have expectations. With the expectations, we can define, okay, what we want to do if we had any violation. We can select, okay, we don't want to drop anything, or we just want to put the data in the results and have warnings. So just some warning that, okay, you have 100 violation, for example. Another option would be we can just drop the rows as violation. So if we have 1,000 rows and 100 errors, we just drop 100 records and put others. Or the last one is fail the whole batch. So if one row was violated, we can fail the whole batch, and then we can find out, okay, what we need to do. The next part are also, there are some other options that we can use. For example, we can add some flags for the data, for the wrong data. So if the data is wrong, we can add a new column or a flag, and then we can reprocess them. Or we can have scenarios that to push or store the good results, correct results to a table, and then bad results to another table. And then we can check the bad results and reprocess them easily, and then again, like a loop, come back to our data. Here also you can see an example of the overview of the data quality that we use for the projects. You can see the written successful data or drop data, and we can also have for which rule they are dropped, number for each rule. So you can easily have good reports based on the data quality. Here also I added a dashboard that it is very good for challenge of the debugging problems and also in development. So we can easily find that if we have a table, if we have a data here, where is the source of the data and how is this data made? For example, with join of tables, with filter of some sources. So we have a good overview here and data quality. Also a schema of the tables we can see here. So if we had a problem, we can easily find that, okay, the problem is from which step, and we can directly go there and find the error or anything that we had here. So it helps us so much for debugging purposes and also development. And the last one for our monitoring that you saw also in the previous presentation by Behnaz and also here. Always maybe we have some problems and we need to have real-time errors. Normally, we can get, in other solutions, we can get an alert when something failed, and for other, we need to define programmatically, for example, for getting the alert. But here with the event log of the Databricks, we can easily define alerts based on the execution. It's like it was success, it was fail, so we can get alerts. Or based on our quality metrics that we had for data quality. So again, if a data is wrong data, but the pipeline was successful, so you can get the alert based on the wrong data, just wrong data. So here you can easily have it. Also, if you had any errors, you can have the error message, for example, easy to find out, okay, what is the error? And for resources, if some days you have anomaly in your CPU usage, for example, or memory usage, you can easily get real-time alerts for the whole pipeline and find out, okay, what was the problem? And for pipeline alerts, we can easily send it as an email, or we can connect them to a Slack, Grafana, any other log management systems, and we can easily store them and integrate this alert system with the other tools that we use in our projects. So Yeah, with delta live tables, we found that, okay, we can actually refactor the whole process of our project, and with the challenge that we had with this new delta live table, so we have jobs, tasks, and the whole pipeline, and made our debugging so much easier. And also on the next levels, we can now have a optimized solution for our problem. Yep. Now, if you have any questions, anything else. Okay.